Hello everyone, it's Kateřina Peková again. I'm Tech Community Manager at STRV and I would like to welcome you all here at our 5th iOS Online in 2021. It's great to see such a great show up and I hope that you will all enjoy the event without any major technical issues. I can see that there are some first-comers, so I would just run through the basic rules really quickly so you can all enjoy this talk and interact with us or with other attendees as much as during the live event. So basically you have many options how you can interact with us. The first one is to raise your hand virtually, of course. If someone do that, we will just unmute you and you can ask your question. You can ask the speaker your question directly. Also, you can write down your question in Q&A section or chat with others in chat. Also, if you are watching our talk or event on YouTube stream, please feel free to write down the questions there as well, and we will make sure that our speaker will get them as well. So that's it from me. And now I would just like to give a word to Jan Pacek, STRV iOS Platform Lead, who will introduce our speaker. So thank you very much and enjoy.
Thank you, Katka. Hello, everyone. My name is Honza, and I'm happy to introduce Honza Kaltoun, who is going to speak today about Swift result builders, which is really a geeky topic. And during the talk, I'll be watching the Q&A and chat while Honza is presenting. So please don't be afraid to ask questions if you like. You can ask questions in the Q&A, in the chat, or raise your virtual hand if you'd like to speak directly with us. And after the talk, we'll have a Q&A session as well, so you can also ask after the talk. So Honza, please take it away.
Thank you, Honza. Too many Honzas, right? Hey, my name is Jan. I'm the iOS department lead here at STRV, and I will be talking to you today about the geekiest topic yet. I think of all the iOS online sessions that we've had so far. Let me share my screen and give you a brief introduction. Okay. So the topic, nope, that is exactly the wrong window. Share screen, this time the correct one. There we are. All right. So this time the topic is result builders, and I would be interested in knowing how many people have actually used a result builder yet, because this has really come in the latest version of Swift, and actually I'm running Xcode beta here, otherwise it wouldn't even work. So I would be interested in knowing whether someone has actually written a result builder yet, and if yes, please say yay in the channel. If not, feel free to stay silent. And I chose this topic because when we're writing Swift UI, we're actually using result builders every single day. With every single view that we have written, we have actually used a result builder, and a special type of result builder in that called a ViewBuilder. So let us actually take a look at what a result builder is used for typically. So let me just super quickly import SwiftUI here. Let me create a structure that will be a test view, and I will conform to the view protocol. Now, this typically has a body property, right, where we put our SwiftUI views that are contained in this one. So let me just put a text here. And now we have already used a result builder because this property is annotated with result builder named ViewBuilder by default. And that means that under the hood, SwiftUI is actually using this result builder to compose all the views contained in this closure. And that is actually the reason why I can put a bunch of stuff here. It actually works. It actually composes those two views together to display them one below the other in this case. And you may have actually used this syntax as well. So you may have used an initializer for this view that would have a property, let's say content, that would be of some type content. That would this view be generic over, something like this. And you may have seen this in some libraries, or you may have used this yourself, or you may have seen this actually in SwiftUI implementation itself. And you would have something like add ViewBuilder var, let's say, content is of type some empty parameters to void, and then you would have something like, oh, well, no vars here, of course. And then you would have something like self-content equals content executed, like this. Now, this is actually, well, this returns content. This is actually another use of the ViewBuilder result builder that is actually provided by SwiftUI. What we're saying is we're going to provide a closure here that returns some generic type that conforms to view, named content in this case. But we are annotating this closure and this parameter with the @ViewBuilder result builder, which means that whenever this closure is executed, Swift knows that it should run this closure through the ViewBuilder to compose the views together. And that is the reason why I can actually do something like this, and it will work, because the result of this is content, which is collected items from that closure when it's run. So you would actually use this something like test view and a trailing closure and text A and text B. So this is typically what the result builders are used for these days, right? The most profound implementation is SwiftUI itself. Now, I chose this talk today, this topic today, to kind of demystify how this thing works, because right now this feels like magic, right? This is pure magic, pure voodoo, because it takes a closure and then does stuff to it, and it spits out a view at the end, or here another view named content in this case. So the purpose of this talk is to debunk, well, not really debunk, but explain this magic. So let's start with that. The goal of today will be to write a JSON builder, which will be a view builder akin to the view builder, a result builder akin to the view builder here used for SwiftUI. The difference is we're not going to be generating SwiftUI views. We're going to be generating JSON objects. And this is an example. You may actually use this in production if you want, something like this, but it's just a perfect example to kind of describe and show how the thing works. Of course, in real world scenarios, you would most likely use still codable. So, I mean, feel free to use this, but you don't have to. But it's a nice example of implementing a result builder. So let's start with what we want to do. We want to start generating JSON objects. And a JSON object looks something like this, right? There's a key and maybe some string, and there's maybe some other key and maybe some integer, right? And there may be even a third key that contains an array of stuff, like, for example, this. Or there may be even a fourth key that would contain a nested object, right? That would, again, contain some key that would go with its own value. And you could nest these things as much as you would like to. Now, the goal of the result builder that we're going to be building today is to provide a SwiftUI-like syntax to generate this kind of string, this kind of object in JSON, but you can send it to an API or do whatever you want with it. I'm just going to comment this out because obviously this is not valid Swift code. So how do we do that? Well, first we need to think about how we would like to kind of use this result builder. And we know that you can annotate properties with result builders as well as closures, right? That are passed, for example, in the init. So the body example would be an example of an annotated property. The init would be an example of the annotated closure. So I want to start with the most basic use case that you would have in SwiftUI, which is the body parameter. Of course, I don't have any body, but I can actually imagine that I have my JSON builder, result builder prepared. And I'll do something like var test is something, right? So I'm saying that whatever this will be actually used for will be run through this result builder that I will run. And let's say that this thing will be returning an object. I will use obj here because object is a keyword, but it's basically going to be my representation of a JSON object. And this guy is going to have a trailing closure. Now, this trailing closure will be akin to your body property in Swift UI, right? This is where I'm actually going to put my own JSON elements that I would like this object to have. So probably some keys, right? Because objects have keys and respective values. So let me just show you a quick example of what I want to achieve, like the most basic thing, and we're going to build on top of that. I want to be able to do something like this. There's a key, let's say example A1, that has a string value. And there's going to be a bunch of those. One will have a integer value. Another one will have a double value. Another one will actually be optional and nil, right? So I would like to have a JSON object generated like this that is basically an object with 4 keys, and all these keys have different values: string, integer, double, and actually null. So this is the most basic thing I want to achieve with my JSON builder, and we're going to do more complicated stuff as we go further. But this is like the most basic example. Now, for this to work, obviously, I need to implement a bunch of things. So JSON Builder doesn't exist, object doesn't exist, a key doesn't exist. So all of these things need to be implemented. Now, I'm going to start with implementing the actual result builder. So let me put the comment here. And what I'm going to say is also example here, because my OCD requires me to write comments. What I'm going to say is add result builder, which is an annotation that indicates that the structure that you will put after this will be a result builder. And I'm going to say struct JSON builder is something. And this is how you define your result builders. You basically have structs that are annotated with add result builder. Now, this is already starting to kind of make sense to the compiler because we're saying that there is a result builder named JSON builder. But obviously, it's not implemented yet, and we're missing a bunch of stuff. So let's start implementing the JSON builder. The JSON builder, as it's telling us right now, must provide at least one function, but we're not going to care about that right now. Let's talk about how the result builders work under the hood. So the way they work is they work on a concept of 2 kind of type aliases, or 2 types, basically. One is called an expression, and the other one is called a component. And you'll see these things all over the place in the rest of this meeting. An expression in a result builder sense is something that represents your kind of data and you compose it together. So this would be a JSON expression. This would be a JSON expression, and this would be a JSON expression. Literally everything that you want to compose together and your users that are using your result builder can include it in the closure is an expression. Then there's a concept of components, which is the internal representation of the composition. Because if you think about it, we're actually composing a tree here. So we actually have to have some kind of a type that lets us construct this tree. And so component is the internal data type that lets us do the construction. So let's define those, and it will start making a lot more sense. So firstly, I'm going to put a type alias here, and I'm going to say expression is some JSON, right? And we're going to implement that in a minute. But the expression, everything that I will be putting here to be composed together is a JSON, which will be a protocol. And this is a view in your Swift UI. This would be a view, basically. Then there is another type alias that we're going to use named component. Component, in our case, will be an array of JSONs. And if I give you an example of what I'm looking to kind of construct, it will make sense, right? So if I simplify this a little, and I just keep these 2 keys here in the JSON, what I'm looking to generate is a tree. And the tree will look something like this. Let's just say key, hello, and key 2, 1, 2, 3, right? So I'm basically aiming to generate a tree like this that could be nested however deep you want, that could be flattened to an object in the end. Well, to one array in the end, basically. And so your expression is the one thing that you want to compose together: a string, a JSON object, a JSON array, an integer, a double, whatever. That's your kind of data representation. A component is an internal representation of this expression, or a bunch of expressions, actually. Now that we have these two components these two types kind of described, we actually can start building using them. And if it still doesn't make sense, which would be completely understandable, it didn't to me at the very beginning, as we develop the first functions, it will start making sense, I promise. But to make the compiler happy, we actually need to implement this JSON type, right? So I'm going to go here. I'm going to say model. I'm going to say protocol JSON. And this protocol will have one single requirement. And that one single requirement will be the actual string that this JSON is going to be represented by. So I'm just going to say JSON string, and it's a gettable property because it's going to be computed for each one of them. Now we have JSON, and the JSON build is starting to be quite happier. This is not screaming anymore. It still needs the function though, but the rest is kind of screaming. And of course it is, because we don't have our object and we don't have our key. So let's implement those as well. This will be our representation of the various specific types that we can use to compose in our JSON builder. And those would be some specific implementations of view in SwiftUI, right? So you have the view protocol, but then you have, for example, text or image, or I don't know, a Z stack. And those would be the objects that I'm implementing right now just for JSON. And, let's implement them. So let's just say struct object conforms to JSON. And now, if you think about objects, an object in JSON has a bunch of things in it, which are represented by key and their values, right? What I'm going to do right now is I'm going to create an internal representation of an object that basically is a bunch of other JSONs nested in it. So I'm going to say var fragments is an array of JSONs, right? And it's our responsibility to make sure that there's just keys. We're not going to do any validation today, but for the simple example, it's good enough. I'm going to implement an initializer. I'm going to say init fragments is of type array of JSON, and I'm just going to say self fragments equals fragments. Now, I need to represent this using the JSON string somehow. So I'm going to say var JSON is of type string, so a computed property, and I'm going to say let contents equals fragments mapped. And I'm going to go through each of these fragments, and I will take their JSON. I will join all these JSON strings with a separator that will be a comma, because if you think about JSON, it's this. It's a bunch of keys and values separated by commas. Now, once that's done, I can actually go and say return curly braces, because that's how JSON objects are represented, and my contents. So we have actually gone and mapped all the JSON values in the fragments array. We have taken their JSON representation, and we have put commas in between them and wrapped everything in the curly braces, which effectively generates a string of a JSON object. Now, you could be much smarter about this, of course. This could be maybe just a bunch of keys, right? Or key value pairs, and it would work nicely as well if you want more type safety. But if we want to end up within an hour, let's not do that. Let's just work with a generic JSON object or generic JSON kind of structures as values of this array, and let's not care about validation. We're just going to trust our users that they don't generate invalid JSON objects. But you could do the checks, of course. Now we have our JSON object finished. let us create struct that is a key. A key in my case will be actually a key value storage. So I'm just going to say key is of type string and value is of type JSON optional, because remember, the values can be nil, as in this example A4. Now we need to do the same thing, right? I'm going to implement an initializer so that I can omit the name so it looks good. I will do omitted key string and omitted value JSON optional. And you may guess it, I will just assign that to the struct instance properties. Now, of course, I need to represent this by a JSON because, you know, JSON requires the JSON string property. So I'm just going to say var JSON. Well, that was not helpful. Var JSON is, and now I need to actually create something like, let's just say quotes key colon value, right? So this is kind of the blueprint that I'm going to be using here. And to get that, I can actually go and say let JSON value equals my value, because it's a JSON, right? So I can actually take this values JSON property, or if it's nil, I can just return null, which is JSON JavaScript representation of nil in Swift world. So this will actually get us the JSON value of that underlying type, or null if it's nil, empty. And then I can go and say return, and here the key we already have, I will replace it, and the value is our JSON value, like this. So now I have created a representation of a key value pair for my JSON. And the last thing I need to do for this kind of a model part of this presentation is I need to create a bunch of extensions here on the basic types, right? Because this is a string, this is an integer, this is a double, but they're most obviously not representable by JSON yet. Fortunately, with the power of protocol-oriented programming, I can say extension string is a JSON, and now string becomes a JSON. The only thing I need to implement here is my JSON property, and that will be very simple. For string, it's a string, so double quotes, and the actual value of the string, right? So this is how you represent a string in a JSON. Then I will do the same for an integer. And you can do this for as many types as you want, of course, but I will do it for just these 3 types. I'm going to say var JSON again is a string, and you may guess it. I will just return a string that is representing the integer, and but no double quotes because it's a number. And for a double, I will do exactly the same thing. I will conform it to JSON, create a JSON property, and again, I will just return a string that contains the number itself. Right? You could be smarter with some formatting or stuff like that, but not for this presentation. We're just going to dump the number as it is in there. And this is what you have to do. Like, this is our internal representation of literally anything that can happen in a JSON. So we're missing arrays, but we're going to add them in a minute. So now that we have these things, the majority of the code has stopped shouting, but there's still a couple of things that we need to do. But firstly, the result builder is screaming. It's saying that the result builder must provide at least one static build block function. And this is the function that all result builders must provide. And actually, it's the only function that all result builders must provide. There's a bunch more that we're going to take a look at, but the build block function is basically the only one that we need to implement. And so if I let Xcode give me the blueprint of this function, you actually see that it works with the components. And we have already defined our components, so I will just keep it as it is. And let's put some print here first, because we'll use it to kind of explain stuff. So I'm going to say print build block for components. Now, a build block function is a function that takes a bunch of components and returns a component out of them. So it basically takes a bunch of stuff and creates one thing out of it. Bunch of internal representations of our JSONs creates one representation to kind of catch them or encompass them all. In our case, since we're getting a bunch of a variadic parameter of components, a variadic number of components, and we need to return one component, and since our components are arrays of JSON, we can simply go and flatten those array into one. So I can just go and say return components, I say, flat map, and a 0. So this will take a bunch of arrays of JSONs, right? And it will create one array of them. Now, this still doesn't make as much sense, but once I actually run it, it will make perfect sense, I promise. So basically, a bunch of components, one component out of them, bunch of arrays, we get an array of arrays, we create an array out of that, because our component is an array of JSON. The internal representation, mind you. Now we're almost there. We just need to implement one more thing, and that thing is the thing that will resolve this rather cryptic error that we're getting here. Well, actually, two things, but first one is this one. It says cannot convert value of type component to specified type object. And if you think about it, it's right, because it's actually saying, hey, so I built this whole thing, and in the end, I got a component, which is an array of JSON. But you're asking me to create an object, and I have no idea how to do that, right? Because I can only create an array of JSON, which is your component. So please tell me, how the hell do I do that? Well, we tell the result builder how the hell to do that using a function called build-final-result. The build-final-result function takes a component and creates a result, which can be literally anything. It could be a string even. But in our case, we want to be creating objects. So I'm going to return an object here. I'm going to print here again. I'm going to say build-final-result. I can't type today. Object for our component that we have just received, right? And I'm going to return an object, and I'm going to use the initializer that I have conveniently prepared before that takes fragments, which is an array of JSON, which coincidentally is my component. So component here. And now I hope it's starting to make sense. So when as Swift, the result builder compiles the expressions that you put into your closure, it creates components out of them. And then the components are flattened together into one big component that is then provided to the resulting type, which is our object in the end, that does all the machinery of actually constructing the JSON strings. So now this is happy. The result builder now already knows how to take a component and generate an object out of it. The only problem is it still fails. And it says, cannot convert value of type key to expected argument type of component. And now it makes sense as well. So it sees that we're providing keys to it, which are JSONs, which is great. But it doesn't know how to create a component so that it can run the build block function on them to, in the end, run the build final result function on them. So we somehow need to take the expression, which is a JSON, which is our key, right? And create a component out of it, which is an array of JSON. For that, we so-called lift the expression into a component. This is how it's called in the documentation or in the proposal, at least the last time I've seen it. And what we need to say is we need to add a function called build expression that takes an expression and generates a component out of it. Now, expression is a JSON, this thing. A component is an array of JSON. So what we need to do is we need to return an array of the expression. So an array with just one element in it, which is the expression that we've just received. I'm going to say here print build expression for my expression. Now, we're using arrays here as the internal representation. A little side note, you could do stuff that is a bit more fancy, something like enum JSON, right? And here it would have cases like, let's say, key and maybe array and maybe object, right? Stuff like this. And then you could use this to kind of construct your internal tree as well. But from my experience, at least, the JSON arrays are super handy in this sense because generics are easy if you need them. You can't annotate the associated values in enum cases with result builders. And also on arrays, you can do stuff like flat map, which is rather hard on the enum stuff. So while you could do that, and I encourage you to try it, I just decided to go for the arrays here as the internal representation because it's just the simplest and it's the most straightforward. So now the compiler is happy and I should be able to compile the code now. So let me run this. And it works. It's just not printing anything. So let me quickly add a print here. Let me say raw JSON. I'm going to say print test.json. Remember, an object is a JSON as well, so I can just get its JSON property as well. Let me run this. And there we are. There is our JSON. It says example A1, hello, example A2, 69, example A3, 4.2, and example A4, null. So this works. It's actually taking the keys, composing them together, and getting us a result. Let's take a look at what it actually does. So as the result builder starts processing this closure, it goes and creates an expression for the key. And it does it actually for all these keys. So that's why you see here the for build expression calls. Then, once it's done iterating over the elements here, it goes and builds a block for them, which is an array of the keys, right? So there we go. We have an array of these keys. Then once it has built the block, it actually has the array that it needs. And it's actually at the very end, right? This is the end. And so it takes the array and calls the build final result function to actually use the component, the array of JSONs that we have created, to create the ending of the resulting JSON object, the OBJ. So basically 4 times build expression, once build block for all these things, once build final result to get the resulting object, and there we are. That's it. That's how we get the object generated, and that's why we can actually run the test.json on it. Now I'm gonna, for the further examples, I'm gonna pretty print this. And I'm just gonna copy paste the code here because I'm lazy to write it. I have prepared it beforehand. But the only thing it's gonna do is it's gonna basically take a data from the test JSON value. It's gonna run it through JSON serialization with pretty printed and just print the resulting string. So let me run that. And we have our lovely JSON here pretty printed. Now, I usually ask questions at the very end, but I would like to ask right now, are there any questions? Does everyone understand what the hell is happening here? Because everything else that we're going to do today is going to build on top of this. Mr. Pacek, are there any questions in the Q&A or chat?
There was one question, but unrelated. So
okay.
If someone has trouble understanding, please feel free to raise your hand or ask a question in a Q&A or chat.
All right. It doesn't seem that there are many, so I'll continue, but please stop me at any point. So this is how we built our very basic JSON object. Now let's make it more complicated. I'm going to comment this out, and I'm going to add an example B. Now in this example B, I would like to be able to nest objects. So I'm going to do something like key example B that has its own value, that is another object. that has, let's say, another key in it, example B1, that says hello. So let me try to run this code. And it's actually going to say trailing closure passed to parameter of type JSON that does not accept a closure. Now we need to do two things here. Well, actually, one thing. We need to tell the object that it can actually accept the trailing closure. That will be a JSON builder to construct itself, right? So in this object, we now have this initializer. And that's actually what it's trying to use desperately, because we have just one initializer. But it's saying, come on, like you're asking me to provide the array of JSONs, but you're giving me some weird stuff. I don't know what to do about it. So what I need to do is I need to implement another initializer that will have one property annotated with our fancy JSON builder that will have fragments as a name and be a closure that returns self. So an object, it constructs itself. And then I'm going to say self equals fragments brackets. So basically myself, I will use the fragments closure that returns myself to initiate myself. Now, since this is a JSON builder closure, it knows how to run this whole machinery to come up with a result. And the result in this case is self, which is an object. And we know how to build the final result of an object. So if I run this, it actually works without any work, actually. So we have a JSON object that has example B key, a nested JSON object that has example BA as its contents, as its key. And so now you probably start seeing the actual power of result builders, because they recursively let you do stuff without you having to basically specify all the nested cases and everything. So this starts to become quite handy. Let us take a look again at what it does. So firstly, the expression is built for the example BA. And it actually works like that. It goes as deep as possible and then traverses upwards. Then it builds a block for it. So it actually creates a JSON expression here out of this, and it lifts it to an array. So there we have an array. Then it goes and builds a final result out of that. So it takes this, which is an array of JSON, lift it to a component. So it gives us array of this item, and then uses it to build the actual object, which is using the flattened array. So basically an array of this key to create the object. Now, once it's done doing that, it goes again and builds an expression for this. So it says build expression for this key, right? So the expression will be, of course, the key with the value of this JSON. So now it goes and builds it. Then builds a block for it. Again, it puts it into an array. And once it's this array, it uses this array to create the resulting object. So it again passes the component that we have just created by lifting this expression, and resulting object is born, which is this one. So basically, build expression and build a component out of it. Build expression and build a component out of it, and build the final result. Build expression and build the component out of it, and build the final result. And this is how it works. So nesting is easy because the same code is being used for both of these cases. It's just nested. And that's what the result builders do for us, actually, rather handily, the nesting. All right, so now we can support nested objects, but what more can we do? How about we create an example C? And in this example C, we are going to introduce arrays. So what I would like to do is something like this. I'd like to be able to say there's a key that will be example C, and it's an array. And in this array, there's a string that says hello. And I can do this because a string is a JSON, right? So it is recognized as an expression. Now, what is not recognized is the R as a pirate, because it doesn't exist and we have to write it. So let's write it. It's actually going to be exactly the same as a JSON, as the object. So I can copy paste this here. I can rename it to R. And here, the only thing I need to change actually is the way how the the resulting string is constructed. So instead of curly braces, there's going to be square ones. And that is it. Array, again, is a bunch of fragments, an array of fragments, right? And we basically need to put them in square braces and separate them by a comma, and that's how your JSON string is created. And everything else works automatically because everything is using this JSON protocol, and we have already implemented that. So right now, we're almost good. If I run this, though, we will get an error that will say cannot convert value of object to closure result type of R. And now, obviously, this is our result builder not knowing how to build arrays. And it's actually very smart. So what it's doing is it's trying to find a build final result function that accepts a bunch of one component, a bunch of JSONs, right? An array of JSONs, and get something out of it. And the only candidate function that it's actually finding is this one that returns an object. But obviously, an object is not an array, so it fails. Now, the only thing that we need to do, though, to actually support arrays is we need to copy paste this build final result and overload it into a result type of array. I'll update the comment and return R here. And magically, it should start working. There we go. We have an array. So we have our object, of course, that contains one key, that contains an array with one item of hello. And that's exactly what we're seeing here. And this is an important thing, though, because here we have actually provided overloads for the build final result function. And this is something that you typically do. You can do this for any of the functions that we have put or will be putting here into the JSON builder. All right, let's go deeper, though. Let's say that I would like to have an example D. I'll comment this out. An example D that does this.
Sorry to interrupt.
Yes.
We have a one question. Could you please show the array type again on the screen?
Yes. The array type looks like this. It actually looks exactly like the JSON. The only difference is that the resulting JSON uses square braces instead of square brackets instead of the curly ones. If there's any question, please unmute yourself and ask away.
Yeah, well, you can raise your hand or let us know in chat if this answers your question. Yep. Okay.
I think we can continue then.
Yep.
All right. So let's go deeper. In this example D, I want to do something even fancier. I want to do something like there's a key called example D, of course, that has to be always a key, that contains an array, which is my JSON array, right? That contains a key named, let's say, well, that contains a string, let's say example D arrays work 2, and then there will be a native Swift array that contains a bunch of keys like this. So 1, 2, 3. Now, what do we need to do to actually support this? Right now, it's saying trailing closure passed to parameter of type JSON, which is an array of JSON that does not accept a closure. And now this means that the compiler is profoundly confused and it has no idea what to do with this thing. Now, we have never told it how to do it, though, because if you take a look at our result builder, and if you remember how it works, for each of the things that are put into the closure, which means, for example, this thing or this thing, we're expecting it to be a JSON. But this thing is not a JSON. So there would be two ways around this. We could also extend an array type with JSON, right? And so provide the JSON functionality for like literally any array that would happen. That could happen. But there's a more elegant way than this. What we can do is we can go and we can override or provide an overload of the build expression function that will be fancy. So let me copy paste this and let's take a look. What do we want to do? So here we're building an expression by default that is an expression. Expression is a JSON. What I would like to do is to be able to build an array of expressions. So let me provide an overload that takes simply an array of expressions. Now I'm going to say build expression array of expressions for the expression as a print. And here, what do we want to do? So internally, JSON arrays are represented as the array type, right? And so I would like to take this array of expressions and convert it to the internal representation, which is my array type. So let me do that. Let me say R fragments is expression, because an expression is JSON. This is an array of JSON, and fragments are an array of JSON. Let me run this. And there we go. We have a key that contains an array. The array contains one element, which is a string, and another element, which is an array of 3 items. And that's how you use the overloads. I just added this example to show you that you can overload stuff rather easily. Let's make it more complicated. Let's say that we would like to support a dynamic generation of the code. So let's say example E. I would like to have a key that is named example E that is an object. But in the object, I would not like to specify the keys statically, but instead, I would like to use a loop to generate them. So there will be always a key that says example E loop underscore my I, and let's just say works. And just to make sure that it all works, let me put the key outside of the loop. Let's name it example E outside of loop. Let's just say works as well. So this opens up a lot of possibilities, because with this functionality, we can actually generate the JSON dynamically, right? Based on some data provided to the function. Now, it says closure containing control flow statement cannot be used with result builder, JSON builder. Now, there's a way we can fix it, and that's actually rather easy. To do that, we need to implement a function in our JSON builder that is named build array. A little confusing name, but it will make sense in a minute. The build array function takes an array of components. Now, we have actually not used that yet, right? So that's why build array. It needs to understand how to build an array of components and create one component out of that. Now, let me just put a print here. And let's say build array for my components. And here, since we're working with arrays and we basically want to flatten everything as much as possible, I'm going to say components.flatMap and 0. Now, why the hell array, you may ask? Well, I'll explain on an example. Let me run this, and it will be rather clear, I believe. So here it's starting to get rather complicated, but let's take a look at what it does. Firstly, it goes and builds an expression for each one of these items. It actually builds an expression and block for both of them. So it goes and creates an expression of the first key, and then builds a block for it, lifts it into a component. Then it does the same for the second one, right? So it goes and basically iterates over the array here, or the range, and runs build expression and build block on both of the results. Now, once we have the results created, it actually goes and builds an array for them. Now, the array is array of components because, you know, build block creates a component, but build array needs to build all these blocks together. So it creates an array of components, which is an array of arrays of JSON. Now, once it's done doing that, it has actually created a component out of that. So flattened array. Again, we're at the component level, so array of JSON. And then it does exactly the same thing as always. It goes and builds expression for this. It builds a block for it as well. So we get a component out of that. And then it does the same for this key, combines them together. It should be somewhere here. Yeah, build block here. So combines the resulting blocks of the for and the key here, and then builds the final result out of that. Actually, I'm one step ahead here. So it builds block for the for and key results, then builds the object using the build final result for that, and then it does the same shenanigan again and again. So it builds the expression for this result, builds block for it, and builds the final result to get the final resulting object. Now you hopefully understand why there's build array, because it basically needs to collect the results of each of the iterations, which gives us a component, and basically flatten the array of components into a component. And so you probably see the kind of general approach that is happening here, right? We get a bunch of stuff that is not a component, and we create a component out of it, and then at the very end we create some resulting object out of that. But that's it. That's it. It's just lifting items into components and then creating components out of components until we actually get the resulting object. Let's go deeper. Let's say we would have an example f here. Oh, it didn't comment out. Please comment out. Let's say we would have an example f here, and the example f would introduce ifs. So let's just say if true, just for the example, there will be a key example f if, let's say, and let's just say works. Now, if I introduce ifs like this, it will say closure containing control flow statement cannot be used with the result builder JSON builder. Exactly the same error as before. And once you see this function, this error, you may guess that we need to implement a function into our lovely JSON builder that will make this possible. The function that we need is named build optional. Now, it is called build optional a little confusingly because it takes an optional component. I will print here and say build optional for my component. And I'm actually going to return the component. And if it's nil, I'm going to return an empty array, which I can do because as we flat map, empty array will just disappear. Now, why is it build optional, you may ask? It is build optional because internally, because all this code is transpiled into other Swift code that then runs these functions, right? And so if you have if, it actually creates an optional property with the result. And if the if passes, it will put some value into that optional property. And if it doesn't pass it stays nil, right, as default. So that's why it's build optional, because this is translated internally into basically an optional value if, and then calls the result function, the result builder function. And so if I run this, it will actually work. And we say example if works. And so that's how you implement ifs. But let's go deeper. Let's create an example G here. And let's say we will want to implement if else, because this is not supported just by doing what we just did. So just say if true, there will be a key that will be named, let's say, example G if is true. Else, there will be a key that will say example G else is false. Oh, by the way, I forgot to kind of explain how the example if works, but you probably may have guessed it. Once you build the expression for this, and once you build the block out of it, which gets you the component, the build optional is run on it, and you get the optional value. And in this case, it has a value. If there was if false, it would be nil, and like it wouldn't be. It would return an empty array. Actually, we can take a look at that. Let me just comment this out. And I can just say if false here. If I run it, it gives me the empty array, right? Because this actually passed through the build optional, and the optional is nil, so there's nothing. So then it does build block for the whole thing. It flattens the nested array, but since it's empty, it actually returns an empty JSON object. So that's how it works. Now, for the if-else case, if I implement code like this and I run it, it will say again, closure contained in control flow statement can be used with the result builder, which tells you that you need to implement the function. Now, if you think about it, a switch is a glorified if-else statement. So this actually gives us, like supporting if-else gives us a support for switches as well. So let's implement some switch. Now for this, I need some model object. So I'll just go and say enum let's just say enum best animal, for example. And here I'm going to say, what are we going to say? Let's just say string and case iterable. And I'm just going to say the two best animals in the world are llamas and alpacas, right? And I'll use this in my switch so that I can switch over something. And so I'm going to say switch best animal dot all cases dot random element. I'm going to say case llama. I will return or create a key that will be example G underscore best is llama. And the same thing for the alpaca, right? So just going to say alpaca here and alpaca there. Now, of course, this will scream as well. The hell? Best animal. What? Did I make a typo? Of course, I did. Okay, let's run it again. Perfect. And it says actually something interesting. It says type JSON Builder has no member build either. And for whatever reason, in the switch, it gives us actually the specific error. In the case of if, it gives us the very non-specific error. But you may guess it, based on this error message, we need to implement a function called build either. And those are actually two functions. Let me show you. So I'm going to go here, and I'm going to say build either first, which will be a component to a component. And this will be the function that gets run in the if case. So here. But there's also an else. And so we need to implement a second function that says build either second, which again is a component that returns a component. Now let me print here, and I'm going to say print build either first for my component, and I'm going to return the component. As I don't really want to do anything too special about it. And you actually don't need to do anything special about it. You could if you wanted to, but the only thing that the result builder actually wants is for you to say, yes, I support this. And that you do by kind of transforming the component to a component in case of if else. And here I'm going to do the same thing. So I'm just going to say second. Now, if I run this code, it doesn't work, of course. And I think it is because it is optional. So I'm going to be a sinner. I'm going to say for some rep. Let me run this again. And there we are. And it works. It says example G if is true. Example G best is alpaca. So let me change this to false. And it will say, hopefully, something different. It will say example G else is false. And example G best in this case is llama. We got lucky because the random elements were not the same in the two executions. So let me return it to true, and let's take a look at how it actually runs. So in the first example, it goes and builds expression for the key example G if. So for this one, it builds a block for it, right? So this is a component now. And it runs the build either first function for it, which returns a component, which is the component that we just created by lifting the key into a component. And then it runs build expression and build block, right? And so we get the result of this. If I would put a false here, though, it would say exactly the same thing, except it would say build either second. So basically, the functions are run based on which branch is basically returned or valid, which passes the if statement. Now the switch does exactly the same thing, because if you think about switches, they can be translated to a bunch of if else's, right? So it goes and says build expression for example G best with the value of alpaca, which is the random element that we got. It builds a block for it. It builds either second for this one, and then it lifts the whole thing into a component because that's an expression, right? And then returns the resulting JSON object. And that way we get our lovely JSON object here, represented by obj. And that's literally it. This is how you use the result builders to basically create your own domain-specific languages. Because if you think about it, I have done a bunch of stuff here. Let me uncomment this. And this stuff actually translates to a domain-specific language created to generate JSON objects. So if I run this, it should actually still work and give me a rather pretty JSON. And it does. And so with this, you have gained rather huge power, because you can use this same thing to generate literally anything. So you could generate an HTML, for example, from it, right? Or you could have a templating system based on this for your Vapor views, for instance. Or you could generate literally any other UI on any other platform. And maybe that is the future of Swift, because with this, you can do literally anything. And that's what I wanted to show you today. I hope it made sense out of the magic when you say var body some view in SwiftUI. And next time you create a view, you will at least a bit understand how it works under the hood. And thank you so much. Are there any questions?
Thank you, Honza, for the presentation. We have one question in the Q&A. If there's a question, if you're going to be sharing this playground to the attendees.
Sure. Yes, we'll send the download link in the email.
Perfect. And There is one more question: if Result Builder can be used for animations, which is sounds like an interesting idea, right?
Actually, yeah, why not? Yeah, it could. Like, yeah, I've seen people using it for all sorts of stuff. So there's one article by, I think, John Sundell, if I'm not mistaken. I hope I'm not attributing someone else though. But I think it was him on his blog that created a simple result builder for constraints, for example, to basically like compose constraints together and apply them to a view. So yeah, you could definitely use it to compose animations. It literally can be used for anything that is to be composed.
Yep. As the attendee suggests, we can build complex animations that are changing under different scenarios. Yep.
Oh yeah, that would be actually cool. Please write the library.
Yeah, send us a link to GitHub. And Katka, do we have some questions on YouTube?
No, there are none.
Okay.
Could you please share the GitHub link in the chat? We will actually, yes, I will put it on GitHub and we will share the link with you. I will not put it into zip. That's ugly. So I'll put it on GitHub and we can share it.
Perfect.
All right. If there are no other questions, thank you so much for listening to me for an hour about this very admittedly geeky topic. This is something rather heavy, but also very fun. So from time to time, you know, we can enjoy ourselves. And greetings to Macedonia in the chat. Thank you.
Okay. So if there are no other questions, I think that's it. I would like to thank everyone, to our speaker, moderator, and to you attendees. It was a great event, and the next one we are preparing would be a Flutter workshop happening on 6th of May. And I can promise that we will work on another iOS talk, which we will post on Eventbrite site, or you can check out our event section on strv.com. So to make sure you don't miss anything. So, and since we want to be proud of everything we do at STRV, we would really appreciate your feedback. So please feel free to fill in the form. I'm posting it right now to the chat, and also you should be able to see it once you close your Zoom window. So it's really appreciated. Thank you very much. Enjoy the rest of the evening, and that's it from us. Thank you. Bye-bye.
Thank you, everyone.
Have a good day.
Bye-bye.
Bye-bye.